Hello? Can you hear me? Okay, good evening, good evening. Sorry, I was not getting connected. Actually, Zoom got uninstalled and so it became late. And after that, mic wasn't working. Okay. Anyways, today we are going to start determinants. Already we covered matrices in the previous class. Now today we will go to determinants. In determinants, we will learn some important formulas, which is called as synopsis. If you know these formulas, then we can do determinant problems easily. What is determinant? First of all, you must have a square matrix. The order of the matrix can be anything. So let us take a square matrix of order n. Order can be 1, 2, 3, 4, 5, anything. But it must be a square matrix. Then the matrix can be associated to a number that is called determinant. Usually how the matrix A will be 1, 2, 3, 2, 1, minus 1, 6, 4, 2, something like this. This is matrix. And what is matrix? It is arrangement of numbers in a form of square. This square matrix, particularly square matrix, the numbers are arranged in the form of a square. That is matrix. But if you associate a matrix to a number, any number, that is called determinant. If you associate to it, if you say that it is equal to number, that is called determinant. And how will you write? Determinant of A, we will write like this. Determinant of A will give you some number as the answer, not like this square form. You'll get a number. Suppose A is a matrix of order 1. That means 1 row, 1 column. If such a matrix you have, and say in that matrix only one element is there, because there is only 1 row, 1 column, then what will be determinant of A? It will be A only. But suppose if you take matrix A as of order 2 by 2, that means there will be 2 rows, 2 columns, like this square matrix, 2 rows, 2 columns. How will you find determinant A then? What will be determinant A? Multiply A and D. AD minus multiply B and C. That is AD minus BC. This is how you will write the determinant. Difficulty is about the matrix A, which is 3 by 3 order or more than this. Like suppose if you have A, B, C, D, E, F, G, H, I. How to find the determinant? There is one easy way to remember. If you want, you can use that way to remember. Or there are many other ways also to remember the determinant. What I will tell you is, first take any 1 row or 1 column. Suppose if I take this first row having ABC. Now when I have to find the determinant of A, I will take A, I will take B, I will take C. I will take alternate signs. A, I will take positive. B, I will take negative, minus, and C as again positive. And now I have to multiply these with determinants. What determinants I have to take? For A, I have to leave, see A, I have to leave the A row and A column. Cut the A row and A column. What is left? E, F, H, I. That makes a determinant. Okay. Now, for B, which determinant I will take? B is here. So, cut the B row and cut the B column. What all are left of? D, F, G, I. Lastly, C. Where is C? C is here. Which determinant you will use? Cut the C row, cut the C column. What are left of? D, E, G, H. So, A you will multiply with. Determinant is easy, I told you. EI, multiply EI minus FH. Minus B into this determinant, DI minus FG plus C into the last one, DH minus EG. And now, when you multiply, what will you have? AEI minus AFH minus BDI plus BFG plus CDH minus CEG. This is the determinant of 3 by 3 matrix. As I told you, there is another easy method. If you understand this method, that is okay. Those who did not understand, I'll tell you another method. A, B, C, D, E, F, G, H, I. You have to find determinant of A. So what we will write is the first two columns we will write again outside. A, B, D, E, G, H. Just repeat the first two columns. Now, how will you multiply? You see here. The way of multiplication is different. A, E, I. These three you will multiply. That is the first step. Then next, crossway. B, F, G. So plus B, F, G. Plus C, D, H. C, D, H. You will multiply. So now all these are plus. Next, you have to go to minus. Now all will be minus. What all I will write here? Minus. This time opposite. B, D, I. Minus B, D, I. Minus crossway only. A, F, H. A, F, H. Minus the last one, C, E, G. 3 plus 3 minus. This is how you can multiply and find the determinant. So this is another method, easy method to find determinant. When you do fast, you can learn this method of finding the determinant. Okay. So now we have some properties of determinants. Let us see what are the properties of determinants. Properties of determinants, because some determinants will be very difficult. If you use the properties, you can make the determinants easy. That's why you must understand these properties. Actually, I'm taking only 4 properties, important properties. What are the 4 important properties? These. The first one, the value of the determinant remains unchanged if rows and columns of the determinant are interchanged. What do you mean by this? I'll show one example. Suppose I'm giving you a determinant. Determinant of A. Determinant of A, B, C, D, E, F, G, H, I. Now suppose if I interchange the row, first row to first column, I'll make the second row as second column and third row as third column. Then I will get a new matrix A dash. Its determinant when you find, it will be same as determinant of. That is what the first property tells. Even if you change the rows to columns or columns to rows, the value of determinant remains the same. How this property used? How we will use this property? While doing the problems, I'll tell you. Next, we will go to the second property. What is the second property? If any two rows or columns of determinant are interchanged, then sign of determinant changes. Now, the second property is, suppose determinant A is determinant of ABC, DEF, GHI. Now, I will interchange two columns. That means, first column I will write as third column, and third column I will write as first column. But second column is same. Then suppose this is the new matrix B. When you find its determinant, the value will be same as determinant of A, but the sign will change. If this sign is positive, this will become negative. If this is negative, this will become positive. Like that, the sign will change. Determinant of B will be minus of determinant of A. That is what the second property says. Okay. Next, third property. If any two rows or columns of determinant are equal or identical, then the determinant is 0. Okay. Now, suppose determinant of A is ABC, DEF, ABC. That means you can see here two rows are same, identical. Then directly you can write determinant will be 0. Same way, if determinant of B is A, D, G, A, D, G, B, E, H. What is happening here? In this determinant, two columns are identical, same. Then also the value of determinant will be 0. In the previous one also, previous property you see here, I am taking the first column to third column to first column. If you want, you can interchange the rows. Suppose if I write determinant C as, I will write the first row as the second row and the second row as the first row. The third row is same. Then what will happen? Its value will be same as determinant of A, but sign will be different. If you want, you can change in the other way also. What did I do here? I changed the first row to second row and second row to first. Like this also you can. So all these properties are for both rows and columns. I need not specify. It is applicable to both rows and column. Each property, not only this property. Okay, fourth property, if each element of a row or column is multiplied by a constant value k, then the value of the determinant originally obtained is multiplied by k. So, suppose determinant of A is determinant of ABC, DEF, GHI. Suppose in this determinant, I will take the third row, GHI, and I will multiply by K, third row. Whereas I will keep ABC same, DEF same. Then I'm getting a new determinant B. This will be nothing but the value will be K into determinant of A. The same answer you will get, but that answer you will multiply with K. That will be the answer. Not only row, even column. Suppose I will make a new determinant C. How? How to make the new determinant C? What should I do? Second row. Any row I can take. Second row I will multiply by B. KB, KE, KH. First row I will keep same. Third row I will keep same. So the answer will be same as determinant of A but multiplied by K. This is the fourth property. So I told you with examples. Next is using determinant, we can find area of triangle. How? Suppose there is a triangle. The vertices A, B, C are x1, y1, x2, y2, x3, y3. And suppose you have to find area. What's the area? Formula with the help of determinant is 1 by 2 into determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. This is the formula to find the area with determinants. But then, how will you find the determinant? One easy method I told you. Write first column and second column again. Repeat it like this. x1, y1, x2, y2, x3, y3. Then what you have to do? You have to multiply this way. 1, 2, and 3. This way. So what I will write here? Half outside. x1, y2 plus y1, x3 plus x2, y3. After that, how will you multiply? Crossway. Like this. This one, and this one. So now these all will have minus. Minus y1, x2 minus x1, y3 minus y2, x3. That's it. That will be the area of the triangle. Yes, I'm here. Very good. Okay. Now we will learn how to find minor of elements of matrix. Suppose there is a matrix A. In the matrix A, I have A11, first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third column. Elements like this. If I have to find minor of A11, what will be the minor of A11? How will you know? A11 is in this row and in this column. Remove it. What you have left? A22, A23, A32, A33. Determinant of, find the determinant of this. Multiply A22, A33 minus, multiply like this, A32, A23. This is minor of A11. Like that, for every element you can find minor. Not only for A11, you can find for every element. For example, you will find minor of A12. That is M12. Determinant of what? Remove the A12 row, remove the A12 column. What are left? A21, A23, A31, A33. Now multiply, find the determinant. A21, A33 minus A31, A23. This is how you will find the minor. You can find the minor of any element like this. Suppose I have to find the minor of A22. How will I find the minor of A22? A22 row I will remove. A22 column I will remove. So minor of A22. That will be left of ones. A11, A13, A31, A33. So how will you find the minor? Multiply like this. A11, A33 minus, multiply like this. A31, A13. This is how you get the minor. For any element, you can find. Similar to minor, there is cofactor. Cofactor of elements of matrix. Suppose there is a matrix A. Which is like this. First row, first column, first row, second column, first row, third column. Second row, first column, second row, second column, second row, third column. Third row, first column, third row, second column, third row, third column, like this. Now you have to find cofactor of A11. This is cofactor of A11. How will you find? It will be same like minor of A11. Only extra thing is you will take minus 1 power 1 plus 1. Because you have 1, 1, so 1 plus 1. That means minus 1 power 2. And what is minor of A11? A22, A23, A32, A33 determinant. So I know minus 1 square will be 1. So just A22, A33 minus A32, A2. This is how I will find the cofactor. Next, for any other element, I will take. Let me take cofactor of A23. A23. How will I take the cofactor? Minor of A23. Then I will multiply minus 1 power 2 plus 3. So minus 1 power 5 I will have. And then minor of A23, what it is? Determinant of A11, A12, A31, A32. Now, minus 1 power 5 is minus 1 into A11, A32 minus A31, A12. Or in other words, minus A11, A32 plus A31, A12. This is what I have. Again, one more example I will give you. Suppose I have to find minor of A31. Cofactor of A31. Cofactor of A31. I have to take minor of A31, multiply with minus 1 power 3 plus 1. So minus 1 power 4 and minor of A31 is A12, A13, A22, A23. Minus 1 power 4 will be anyhow positive. Now when you find determinant, what will you get? A12, A23 minus A22, A13. That's it. Like this, you can find cofactor of any element in the matrix. Now we will do some questions. Based on this topic, I'll give you some questions. Still we have determinants, but we will do it in the next class. I'll give you the question, you try. Here is the first question. Please try. Reshma and Noor are saying option A is the correct answer. But option A is not the correct answer. It is not like matrices. Don't compare 2x with 6. Don't compare x with 3. In matrices, you do that. Yes. Vinushri is correct. Not option A, not option B. Option C is the correct answer. How? I'll show you. First, find this determinant. 2x square minus 40 equal to 18 minus 14. So it will become plus 40. 2x square minus 40 equal to 32. 2x square is 40 plus 32. 2x square is 72. X square is 36. X is plus or minus 6. So option C is the correct answer. I'll give you the next question. You try this. First of all, what is singular matrix? If determinant of A is 0, that means A is singular matrix. If determinant of A is not 0, that means A is non-singular matrix. So I'll give you this question. Try. All of you are getting option B as the answer. But that is not correct. I told you property 1. That property you have to use. What is that property? First of all, in matrices you have learned, if you have K into A transpose matrix, it is same as K into A transpose. This is about matrices. So, if you have K into A transpose, and if you are finding the determinant, it will be K into determinant of A transpose. But according to property 1, determinant of A transpose is A only. Whether it is A transpose or A, it is same. So first what we will do in the question, determinant of 2 into A transpose will be 2 into determinant of A transpose. And determinant of A transpose is determinant of A only. Determinant of A transpose is A only. Okay. So it has to be 2 into determinant of 5. Determinant of A matrix is 5. It has to be 10. But this formula is applicable if matrix A is of order 1 by 1. 1 by 1. Suppose I will take this formula for A is a matrix of order 2 by 2. Then what will be the formula? K into A transpose determinant will be equal to K square into determinant of A transpose, that is K square into determinant of. So if you have 2 into A transpose, that will be equal to 2 square into determinant of A transpose. That will be 4 into determinant of A. Determinant of A is 5, so it will be 20. But this is for matrix of order 2 by 2. If matrix A is of order 3 by 3, then K into A transpose, if you find the determinant, it will be K cube into determinant of A transpose. That is K cube into determinant of A. Yes, no. B is the correct option. So, when you have 2 into A transpose, it will be equal to 2 cube into determinant of A transpose. That is A into determinant of A. And determinant of A is 5. So, it will be 40. Answer is 40. Option D. Okay. Next question. ఏంటి కాల్ చేసావు? ఇంట్లోనే ఉంది. మీ ఇంట్లో? మా ఇంట్లో ఉన్నాను. అక్కడ ల్యాప్టాప్ లో జూమ్ లేదు. ఇంకా లేట్ గా స్టార్ట్ అయింది. 7:50 6:50కి స్టార్ట్ చేశాను. అక్కడికి వెళ్ళాక గుర్తుకొచ్చింది నాకు జూమ్ లేదని. అందుకని మళ్ళీ పరిగెట్టుకుంటూ గబగబా ఇక్కడికి వచ్చాను. ఇప్పుడు ఇక్కడ స్టార్ట్ చేసేసరికి 6:15 అయింది. అక్కడ 7. గుడికి వెళ్తాం. Bye. No, Lokeshwari, D is not the correct answer. Nirmala, you are also wrong. Yes. B is the correct answer, Nirmala. Nirmala got the correct answer. What is the area of the triangle formula? 1/2 into determinant of -301, 301, 0K. But already they gave you area is 9. So what I will do, 1/2 into, how will I find the area? I told you. You have to write the first two columns again. -30, 30, 01. 0K. First two columns again. Next, what will you do? Multiply this way, this way, this way. So you'll get 0 plus 0 plus 3. Next, you have to multiply this way, this way, this way. So -0 minus of -3 plus 3K minus 0. This is what equal to 9. So your 6K equal to 80 or K equal to 3. The value of K is okay. I'll give you the next question. To answer this question, I have to give you one shortcut formula. If a matrix A is of order, square matrix of order n by n, then determinant of adjoint A if you have to find. There is a shortcut formula. It is determinant of A power n minus. This formula you use. Find the answer for this. No, Reshma. I think without doing, you are telling the answer. No, Noor is wrong. Nirmala is wrong. See, A is of order 3 by 3. They are asking you determinant of adjoint A. It will be determinant of A power 3 minus 1, n minus 1. Determinant of A squared. Determinant of A is minus 4. When you square it, it will be 16. So option D is the correct answer. Last question, one more question. Before putting this question, I have to say, if there is a matrix saying, then A inverse will exist only if A is non-singular. The non-singular means what? Determinant of A should not be seen. Then only A inverse will exist. Okay. I am putting this question. Try. Yes, Pallavi, D is correct. I said, if you want A inverse to exist, determinant of A 2 lambda minus 3, 0 to 5, 1, 1, 3 should not be 0. So how will you find determinant? Repeat the first two columns, 2 lambda, 0 to 1. And then cross multiply like this. So what you will have? 12 plus 5 lambda plus 0. And then cross multiply like this. So minus 0, minus 10, minus of minus 6, so plus 6, not 0. 5 lambda, 12, minus 10, 2, plus 6, 8, not 0. 5 lambda not equal to minus. Lambda not equal to minus 8 by 5. It is not present in any of the options. So none of these. Option D is. In the next class, we will do some more questions. Till then, practice more. See you in the next one.